Alright, so in this lecture, we will examine the heterogeneity in the relationship between a pandas series object and the NumPy array structure. That's why we will import the two relevant libraries this time, pandas and NumPy. Let's take prices per category as an example object. This will be a series representing the prices of categories containing products of types A, B, and C. We've denoted the categories as product A, product B, and product C. For starters, we refer to the values attribute. It returns namely the values of the series stored in a NumPy array. It also indicates the data type of the values. In this case, they're all 64-bit integers. What is interesting here, at least at the moment of the recording of this video, is that the pandas developers recommend not to use .values. As a rule of thumb, when you encounter such a warning in the documentation, it means that you need to immediately start applying the given suggestions. They reflect how the functionality in question will be used in future versions of the language. In this situation, we have been advised to switch to the array attribute or the toNumPy method, and we'll see why in a minute. As we execute prices per category .array, we obtain the same integer values in a different format. The type function confirms this is a pandas array. This type of object also contains underlying data, also known as full data. An example is the information about the length of the array. The main benefits of using a pandas array can be further explored in practice. What you need to remember now is that it has been built on top of the NumPy array. More precisely, it acts as its extension, which in programming terms means that it extends the capabilities of the NumPy array. In this particular case, the pandas array object has been created to respond to certain needs of the library. On that note, the documentation explains that pandas knows how to take an extension array and store it in a series or a column of a data frame. Moreover, as we check the description of a pandas array, we read that it exists to improve internal compatibility. Therefore, this type of object will be used when your work is exclusively centered around the functionalities of the pandas library. Good. If we are looking for a really direct relation between the values of a series object and the NumPy array structure, then it is the pandas to NumPy method that will convert the series into an absolute classical NumPy array. This type of conversion allows you to proceed with mathematical and statistical computations or further pre-processing of your data, something peculiar to the NumPy library itself. Historically, this method has been introduced to satisfy the increased demand for improved transformation of pandas series into NumPy arrays. That's why the toNumPy method has parameters that can indeed enhance such type of structure conversion. For instance, by using a list of strings, we can designate the index values corresponding to the first two rows of the series, product A and product B. Then we can apply the toNumPy method and pass the float string as a value of the dtype parameter to directly indicate we would like to turn the integers into floats. Then, if we store the output of this operation in a variable called testArray, we can easily observe two floating point values. Great! Further discussion on the three techniques we covered in this lecture will only come after gaining a certain amount of coding practice. Therefore, please remember just the following features of the three approaches for now. They will all convert your series into an array. In fact, if we don't provide any values to the parameters of the toNumPy method, all three will return the same result, arrays containing 64-bit integers. See? Then, in many situations, your preferred method will be irrelevant for the final result. Nevertheless, we need to be very careful when aiming for the correct conversion. The values attribute was used in the past a lot, so you will encounter it in the literature, in an online search, or old code. However, by all means, we should comply with the recommendations provided by the pandas developers themselves. So we suggest you avoid using that tool when you need to convert your series into an array. So, what we are left with are the advanced capabilities of the pandas array, or the classical NumPy array, since we always strive for consistency, as suggested by the documentation. We are supposed to start using, or as you might also hear it, to migrate towards the newer tools. This way, we can solve compatibility issues that programmers have encountered in the past. To sum it up, .array will convert your series into a pandas array, which is an extension array. This type of object will be useful in making calculations in pandas, as you will also be able to take advantage of the underlying data. Alternatively, when we want to organize our information into a pure NumPy array structure, we can use the 2NumPy method and its features. To conclude, depending on the situation, we will use the second or the third option, though sometimes the functionality might be covered by the first technique as well. This was a technical and yet very important lecture that will surely contribute to raising your future coding standards. Thank you for watching.